Tiny motion sensors, known as accelerometers, are at the heart of much of today's technology. Built into a smartphone, for example, the sensor detects both movement and the angle at which the phone is being held to trigger the rotation of the screen. This little chip is why a smartphone knows when it has moved. These motion sensors are tiny but smart because they can detect every move. They start with silicon discs called wafers. Each wafer will be used to make thousands of motion sensors. A technician aligns the discs in a cassette, using the flat part of each one as a reference point. Once properly aligned, a mechanism lowers the silicon wafers onto a carrier made of quartz, which can withstand intense heat. The technician loads the wafers into the furnace. Inside, the 2,000-degree heat and steam cause an oxide to form on the surface of each wafer. It'll act as an electrical insulator. Then it goes into what's known as a sputter system. Here, inert gas ions bombard aluminum, causing it to sputter onto the wafer until an even layer accumulates. This aluminum layer will serve as a conductor of electricity. The next machine deposits a light-sensitive chemical onto the wafer. The wafer spins, allowing the chemical to flow evenly across the surface. This all happens under the glow of yellow light. To prevent the untimely activation of the chemical, which reacts to bright light, just like an unexposed photographic negative would. They're now ready for that bright light. UV light beams through tiny patterns on a glass plate to activate the light-sensitive chemical. The patterns transfer to the wafer surface, forming an outline for thousands of motion sensors. Another chemical then flows onto the silicon wafer to further develop these minuscule images. Next, lasers locate the wafer's flat edge, signaling a chuck to spin into its proper position for plasma etching. The etching creates thousands of free-moving 3D structures. Each one is a motion sensor. After etching, a sprayer blasts the surface with carbon dioxide. It's the only way to clean it without damaging the now movable sensors. At the next station, a robotic arm flips the wafer into position. A tray moves under the robot and places the wafer on it. The tray retracts and loads the wafer into a clamping system. It then collects a second silicon wafer and places it on the first one in the clamp. The second wafer acts as a lid to protect the individual sensors. Held in the clamp, a machine heat seals the two wafers, and the bond is complete. Next, a computerized saw cuts grooves into the top wafer only, while a steady stream of water keeps the dust down. The saw exposes the aluminum layer on the bottom wafer, something that will allow each sensor to make an electrical connection. A platform now moves the wafer a millimeter at a time, so that a probe can test each sensor and confirm it performs correctly. This continues until every sensor on the wafer has been tested. From a plain silicon wafer to a unit that contains thousands of motion sensors, this process takes 3 weeks. After the individual sensors have been cut and encased in plastic, they're ready for a final test. A robot loads each sensor into a test socket. The socket both tests the sensor's performance and programs it to customer specifications. A robot packages the sensors for shipping. And once installed in phones, tablets, and computers, these motion sensors will be ready for action.